better graphics, or you want better better display or something, you put in an adapter card, and then it makes the computer function better. We also have ports. So ports, as you all know, where you can slot your mouse, your keyboard, and then other ports, right? And then we have the drive bays. So the drive bays are slots in the computer where we can install hard drives. Okay, you can. So if you want to expand your hard drive or something, we have the drive base where you can input your hard drive. Then we have the power supply. The power supply, that is what gives the computer power. So basically it converts DC to AC. Okay, we'll talk about that also later on. So we first start with the CPU. When you say a CPU, right? What is a CPU? So a CPU, every computer has at least one processor, also called a central processing unit, right? The CPU. It contains millions of tiny transistors and pathways that takes in data and instructions, process the data according to instructions, and output the results of the calculation, right? So the CPU is like the brain of the computer, right? The CPU is the brain of the computer. So it directs. So CPU is the brain of the computer. So it takes in instructions, it processes them, and then it outputs results, right? That is what the CPU does. Basically, it takes in instructions, then it processes them, and it outputs them. Just like we all have brains which we use to think, that is how the CPU also in the computer works. It thinks for the computer, all right? So we will move on to the components of the CPU, the central processing unit. So we have the control unit, right? So the control unit manages the flow of data through the CPU. So the control unit is what directs, it acts like a traffic controller, right? So it directs data to the other components of the CPU, like the ALU and the registers and memory. Is the control unit that directs data to those parts of the CPU, right? So it acts like a traffic controller, just as I said. So it manages and directs the flow of data and instructions within the CPU. All right. So then we move on to the arithmetic logic unit. So it's what does the actual processing, right? The ALU is what does the actual processing, that is the calculations and then the logical operations. So the additions, subtractions, and the decisions, it's the ALU that makes. So whenever you input a number into a computer and then it gives you, if you input 2 + 2 and it gives you 4, you should know that it is the ALU that has done the background work to give you the output of 4, right? So that is what the arithmetic logic unit also does. So it does operations on the data. Then our next one is registers. So registers are temporal memory holding areas, okay, for data and then instructions. So we say that they store data. All right, so I'm too fast, sure. All right, so when we say a register, right, a register is a temporal holding area for data and what? Instructions. So when the CPU is working on something, right, it keeps the data and the instructions in the registers temporarily, okay, so that when it needs it, it can immediately have access to it and use it. So the registers are not permanent place where the CPU stores data, but then that is where it keeps its instructions and data whilst it's working on something, right? So that is what the registers does. It keeps the instructions and data temporarily. All right, so since I've been able to see the main components of the CPU, that is the ALU, the registers, and then the control units, you will now look at the machine cycle. Okay, so the machine cycle is how the computer takes in data, how it processes it, and then how it outputs it. All right, that is basically what the machine cycle is. So we first start with the first one. Okay, so we have fetch, we have decode, we have execute, and then we have the store or display, sometimes also called display. So we will start with the fetch, right? So the fetch, that is the control unit requests the data and instructions it needs to be fetched from memory and moved into the CPU, right? So the fetch is like retrieving instructions from the memory, right? So let's say you input add total sales, like your business student. So maybe you are inputting something like add total sales from, let's say, today into the computer, right? It is the computer will first fetch this instruction that you have inputted from memory. Okay, so that is what the fetch is basically about. That is just like retrieving the information from memory. Okay. Then after fetching the information, it goes on to decode it. So decoding, of late, the guys normally you say decode when you send someone say something that is abstract or something you don't understand, then they are like, you decode it, right? So it's like bringing it into something that we will understand. Okay, so we try to decode something when someone sees it. So it's the same way that the computer also works. It tries to decode the instruction because the computer doesn't understand let's say the add total sales from today that you inputted, right? So it will try to bring it into what it will understand. So maybe it will make it like add these numbers together because that one, the CPU understands that, okay, this is numbers, so it knows what to do with it. But then add total sales from today, it doesn't understand. So it decodes it and gets to understand that, oh, okay, so it means that I should add these numbers, right? So after decoding it, that means it has now understood what it is supposed to do. It goes on to execute it, right? So execute. So that is now the arithmetic logic unit comes in, right? It comes in to process the instructions. So that is when, if you have inputted, let's say 2 plus 2, it executes it and give you 4. That means execution has been done. So now you have an output of 4, right? So that is what the execute state does. And then after it has executed it, that means it is done with the process. So it has first fetched the data, it has decoded it into how it will understand, then it has executed it, it has performed what we said it should do. Then it goes on to store it. Okay, so the results is then saved into memory, all right, or it is outputted to the screen, all right. So this is the basic machine cycle, the process that the CPU goes through to either save a data or project it. So it first fetches it and then it decodes it, make sure it understands it before it works on it. After working on it, then it stores the data or it projects it, right? Okay. So please, are there any questions or am I still moving too fast?
Yes, so
I'm still moving too fast. Okay.
yes.
Okay. So I'll calm down.
Thank you.
You're welcome. So you move on to the physical compositions of the CPU. So now we know how the CPU works. We know what it is, right? And you want to know the things that are in it that makes it work, right? The things in the CPU that makes the CPU work. So when it's physically, a CPU is a very small and thin sheet of semiconductor material, usually silicon, with a complex array of tiny transistors and pathways stamped into it with a die. Okay, so that is basically, we are coming to look at the physical components in a CPU. So we first start with a core, right? So a core, here, most modern CPUs have multiple cores to complete multiple tasks simultaneously. So a core is like different parts in the CPU, right? So each core handle its own tasks independently. Sorry. Right. So let's put it like this. Let's say a football team, right? In a football team, we have a striker, we have the defender, we have the goalkeeper, and all those people. So we can say that all those individuals in the team are out a core. So they are all core, and then they all do their independent tasks at the same time. So the striker tries to score, the defender tries to defend, right? So that is what a core is, basically an individual component of the CPU that works simultaneously. So when you say that most models of the Intel Core i7 processors have 4 cores. So one thing about the core is that more cores, right, means faster work, or that means more work can be done. Yeah, let's say faster multitasking, or more work can be done at a time. So it's like having more employees, right? So if like the core i7 has 4 cores, some CPUs can have 6. I think it's between 6 to 14 now. Some can have 7, some can have 8. So this means that a CPU that has 8 cores can work faster than a CPU that has 1 core. Wait, sorry, 4 cores, right? So a core is like individuals within the CPU, individual components within the CPU that works simultaneously. So whilst 1 core is working, the other core is also working. All right. So now let's look at the second one, which is caches. Right. So in practice, the CPU sometimes is idle because there is a delay between the request for data to be retrieved from memory and its delivery. The cache store frequently accessed data or instructions. Okay, so what the cache does is that if you access a certain instruction frequently, right? If the CPU accesses a certain instruction frequently, the core tries to save that instruction in memory so that next time you need it, it wouldn't have to go through all the process to get to that instruction. Once you just click on it or something, it just should. So we can use, I don't know if some of you have taken notice, but if you access a certain website so many times, for the first time when you access it, you realize the images and the stuff on it, the media are very slow to load. But then when you access it for like 2-3 times, the next time you open it, you realize it loads very fast. So what the web browsers do is they try to cache those websites that you access often. So the next time you come and you are accessing them, they are easy to access. It's the same thing that the CPU caches also does. Okay, so they keep the informations or the instructions that you access often so that it will reduce what latency. Okay, so latency is just the time between when maybe you ask for instruction to be done and then the time that it is done, right? So that is what the cores and the caches do. All right, so are there any questions? All right. So we will now talk about CPU performance factors. So when you say CPU performance factors, is the thing that we see that maybe what will make us say that, okay, this CPU is fast or this CPU is slow, right? So the most obvious factor that affects CPU performance is the speed, right? So the most obvious performance factor for a CPU is its maximum speed, measured in billions of hertz or gigahertz, right? So we measure the speed of the CPU in hertz or gigahertz. And when you say 1 gigahertz, you're talking about like 1 billion cycles like per second. Okay, that is how fast you are talking about. 1 billion cycles per second. So the speed of a CPU is called the clock speed, right? So the higher the clock speed, that means that the CPU is able to process more instructions per second, right? So if the CPU has a high clock speed, that means that it's able to process more information per second. So here it says that if a CPU is pushed to run faster than its rating, for example, by putting it in a motherboard that runs the CPU faster, it is said to be overclocked An overclocked CPU is more prone to overheating, processing errors, and
Hello? Can't hear anything.
No, we can't hear nor see anything.
The sound is awful. We can't hear anything.
Hi, I think savings network went back, so let's give him some few minutes to join back. Steven, are you back?
yes, please, I'm back. So sorry, my internet. All right, so I was talking about the CPU performance before I went off. So I was talking about overclocking the CPU. What happens if you overclock your CPU, right? So it can give you errors, and then it can also make Moses thing on. Can you please mute? Okay. So then we move on to the computer memory. So the computer memory is an electronic chip with integrated circuits that store on or off values. Computer memory is basically a place where we store data and instructions electronically using on or off value. I think last week Doc mentioned that on 1 represents on and then 0 represents off. So that means it stores data in and ones, right? That is what the computer memory does. It stores data in zeros and ones. Right. So we are now going to talk about how computers use memory, right? So when we say memory, some of us think memories are just memories. So the computer uses memory to store data and then that's all. But then we have types of memory. So we have the system memory. Okay, so that is the main memory, right? System memory is the main memory that the computer uses. That is the RAM, right? The RAM. So sometimes you are buying a PC or even phones and you're like, this phone has 2 GB RAM or 4 GB RAM. That is the main memory that the computer uses. So that one, it stores, like I said, it stores data and instructions that the CPU is currently working on, right? So normally it's called the dynamic RAM or the DRAM, right? That is what the RAM is about. Then we have the component memory. So like the components of the computer, right? There are so many components of the computer, but each of them has a memory. So they all don't depend on the main memory of the computer. They all have small memory. So it's many components have a small amount of memory built in for their own use, right? So all the components, although yes, they all use the memory of the computer, but they also have their small memories that they can use for their own task, right? So like a printer, right? Here it gives an example of a printer. A printer has its own RAM, okay? That holds information about the page that is printing. So when you are printing a page, right, the printer doesn't go to the PC to check the page that is on right now, but then it has its own memory that sees the pages that is printing, right? Then the next one is the read-only memory BIOS. I think last week we spoke about the BIOS, the basic input-output. So that is what Doc said. It's the first software that runs when you on your PC, right? So this is a memory on the motherboard that has like startup instructions. So once you on your PC, this memory runs first, right? To see that all the hardwares are working and to make sure that everything on the PC, once you boot it, it makes sure that once you boot the PC, everything is working well. So that is what the ROM BIOS does. All right, so we mentioned caches, right? I think if you still remember, I was like, caches store data temporarily, like they store so that when you come back to access them, it will be easy to access them. So here it's talking about the types of the caches. You have the L1, which is a bit smaller. You have the L2, which is a bit big, and then the L3, which is bigger, right? So we say that L1, L2, and L3 caches in the CPU are a type of static RAM. So all these are types of memory. And then you move on to flash memory. Okay, so it says USB flash drives, memory cards, and solid state drives. As mentioned in the earlier note, these devices use a type of EPROM, which we'll talk about. That is electronic erasable memory, which we'll talk about later. So this type is also called flash memory, right? So this type of memory is non-volatile. So when you say memory is non-volatile, that means when you off your PC or when your PC goes off, it doesn't lose its data. So like our memory cards, our USB drives, and the SSDs, they all have this they are the flash drive, sorry, the memory cards and the solid state hard drives, right? Okay. So these ones, they store data permanently. They don't store data temporal, right? So we come back to the RAM again, right? We spoke about the system memory, but it's here again. That is, we say that this computer has a certain amount of system memory, also called RAM or main memory. It is dynamic RAM. That's, it loses contents if it's not constantly being electrically refreshed. So when you say electrically refreshed, that means once your PC goes off and there is a data on your RAM, you will lose it. So that is how come if you are working on a Word file or you are working on a PPT or something and you don't save it, right? And then let's say there's a light out and your PC goes off. When you come back, you might not be having that same thing you're working on there because you didn't save it. So it was on the RAM. You was keeping it temporary. But if you should have saved it, then it should have moved to the ROM, which would have been permanent, right? So that is the system memory. So this image here is basically showing us the types of memories and then how we can group them. Okay, so we have the ROM, and then we have the RAM, right? So we can group the RAM into the RAM, that is the volatile one, all right? I said volatile means it doesn't store the data permanently. Okay, it stores it only for some time, and then once your PC goes off, it loses it. So we have the static RAM, and then we have the dynamic RAM. Okay, so we'll talk about the static RAM and dynamic RAM later on. But the static RAM means that it doesn't refresh itself. Okay, so it's just that it doesn't refresh. But then dynamic means that it's refreshing itself every second. That is the difference, the two types of RAM that we have. And then the ROM, we say the ROM is non-volatile. That means that it doesn't lose data. Once you save something and you off your PC, when you on your PC, it will still be there, right? That is the ROM. So under the ROM, you have the flash drives spoke about. You have the EEPROM, and then the EEPROM, the electric erasable ROM, which we'll talk about, and the other one also, we'll talk about all these ones later on in the. All right. So we are still on the random access memory. The random access memory. It is also called read-write memory, or the main memory, or the primary memory. It's a volatile memory. So as the data it's a volatile memory. The data loses when the power is turned off, right? So just as I mentioned earlier, once you turn off your PC, any data that is stored on the RAM, it will be gone, right? That is when we say it is volatile. So the RAM is further classified into two types: the static random access memory and then the dynamic random access memory. Okay, so you take these two types of memory and look into them very well. So when we say let's start with the dynamic RAM. So we see that the information stored in dynamic RAM has to be refreshed after every few milliseconds. Otherwise, it is erased. Okay, so that means that any data that is stored on dynamic RAM needs constant refreshing to keep the data. But if it is not refreshed every few milliseconds, that means milliseconds are very small, so it's always refreshing itself. If it doesn't refresh itself, then that means you lose your data, right? Okay. So then we move to the static RAM. Static RAM, the information stored in static RAM need not to be refreshed, but it remains stable, as long as power supply is provided. So on static RAM, you don't need to refresh. There is no need to be refreshing the memory. It doesn't refresh itself. Okay, so the data is on. Once there is power, that means, so there's a difference between the static RAM and the ROM. Don't mistake the ROM for the static RAM. The static RAM, it stores the data all right. It doesn't need to refresh itself. But once your PC goes off, or once there is no source of power, it loses the data. So it doesn't, save data for a long time. It's still, for a short time, but then it doesn't refresh itself. That is the only difference between the dynamic RAM and then the RAM. All right. Please, are there any questions? Okay, so if there are no questions, then I'll proceed. So now we are moving on to the ROM, or the read-only memory. Okay, so the read-only memory stores crucial information essential to operate the system, like the program essential to boot the computer. So the ROM, or the read-only memory, is a type of memory that stores crucial instructions, okay, needed to start and operate a computer. That is basically what this is saying. And then it is non-volatile. Okay, it's not volatile. That means it's non-volatile, which means that it keeps data even when the power is off, right? So it always stores programs. It stores programs essential for booting the computer. Okay, then it always retains its data, right? And then normally the ROM cannot be altered. Okay, that is why it is called read-only memory. Okay, it cannot be altered by the user normally. But then let's look at the classifications of this ROM. Okay, it can be classified into four types, which we have seen some earlier, and I was like, we'll talk about them. So we have the programmable read-only memory, right? So this type of ROM, right, the information is stored by the programmers after its manufacturing. So once this type of memory, the programmable read-only memory, has been programmed by the manufacturer, then any information on it cannot be altered or erased later on, right? Any information that is on this type of ROM, the programmable read-only memory, after it has been manufactured, cannot be altered. So the user doesn't have any, way to alter information on the programmable read-only memory, right? Then we move on to the erasable programmable read-only memory. So this one is also, it is similar. It's similar to the programmable read-only memory, but this information can be erased later on by ultraviolet light, and it can be reprogrammed. So the only difference between the erasable programmable ROM is that this one, after it has been programmed by the manufacturer, we can use ultraviolet light to clear it, and then we reprogram it. Okay, that is how the ROM is. And then we have the EEPROM, that is the electrically erasable programmable read-only memory. So this one is also similar to the one we talked about before, but just that this one, to be able to erase the data, right, you need electricity. That is why it's called electrically. So we need electricity to be able to clear it, and then we reprogram it. All right. So that is the difference between the first one. The EEPROM uses ultraviolet, and then the EEPROM uses what? Electricity. Sorry. Then we talk about the last one, which is the EAPROM. So that one is electrically alterable read-only memory. So as compared to the EEPROM and EEPROM, the information stored in the EEPROM can be altered later. So this one, you don't need ultraviolet, or you don't need electricity to clean it, but then it's easy to clear it and then reprogram it, right? So that is the difference between the types of ROM that we have. Please, are there any questions? If you don't understand anything, you can ask for clarifications. All right, so let's look at some difference between the ROM and the RAM, right? So, like I said, the ROM is permanent storage. It stores data permanently. The RAM, temporary storage. It stores data for a while while the PC is working on the data. It stores it in the RAM. Once you off the PC, you lose that data, right? Then the ROM store data in gigabytes. So that is why when you are going to buy a PC, maybe you say you want a ROM with something a PC with maybe the memory like 428 gigabytes, 500 gigabytes, okay. But then the RAM stores data in megabyte. So its data is not big. That is why you can have a PC with 4 gigabyte RAM, because it stores the data in megabytes. So the 4 gigabyte RAM is enough. Okay. Unlike the ROM that stores data in gigabytes. Okay, then the ROM is non-volatile. So as I said, non-volatile means that you don't lose the data. Okay, the data is always, when the PC goes off and you on it, it's always there. But then volatile means then the RAM is volatile. That means that it loses data. Okay, so once the PC goes off, all data that was in the RAM is cleared. When it starts again, it starts fresh, right? And then we said that the ROM is used in startup process of the computer. And then the RAM is used in normal operation. Then the ROM, writing data in ROM is slower. And then writing data in the RAM is faster. All right. So we move on. We move on to the motherboard. The motherboard. So the motherboard is the main circuit board in the computer. I said the motherboards vary in many ways, including the CPUs and memory they support, the technology used in their chipsets, the expansion slots they have, and the external ports they support. Right. So the motherboard is the main circuit board in a computer, and then it connects all the parts, together. Okay, including the CPU, the memory, storage, and then peripherals. When you say peripherals, let's say you put your mouse or your keyboard, external mouse or external keyboard to your PC. It's a peripheral. So what the motherboard does is that it connects all these parts together to make sure they function very well. All right. Okay. So it said the motherboard's capabilities are determined by its chipset. The chipset contains the controllers that direct the traffic along the motherboard's buses. Okay, so the capability of a motherboard, what a motherboard can do, it's based on its chipset, right? So the chipset is what determines what the motherboard can do. And what the chipset also does is that it controls data flow on the motherboard, right? So it's the one that controls the flow of data on the motherboard. And then also it specifies which memory. It specifies which memory and CPUs the motherboard can use. Okay. It's specified the CPU and memory the motherboard can use. And then it also routes data to expansion slots and external ports. So when you have expansion slots where you can put in more, maybe you put in more you increase the RAM of your machine or something, or so you have the external peripherals you add to your PC, is the chipset that routes data to these parts that you have added, right? So let's look at some key terms, okay? Some key terms when it comes to the motherboard, right? So when we say form factor, we are talking about the motherboard's physical size and shape. Okay, so it's significant because the motherboard must be able to physically fit into the system unit. So you can't have, a motherboard that is bigger than your system unit because the motherboard sits in the system unit. So that is why the form factor is very important. So you need to consider the size of the system unit and then the motherboard, all right? Okay, then expansion slots. So expansion slots are plastic slots on the motherboard. Inside the slots are metal contacts that connect with metal contacts on similar circuit boards called expansion cards that fit into them. So expansion slots is where you can, insert additional expansion cards. Okay, so if, like in the beginning, I said if you want to better your graphics or you want to better your sound or your network, you can add extra sound cards or graphic cards. So those you put them at the expansion slots, right? You put those cards at the expansion slots, and then we have the built-in components. So the motherboard has built-in components for video, audio, and networking. So some features are already built on the motherboard, right? So like video, audio, networking, that is Ethernet and Wi-Fi, they are all built on the motherboard. So that is the built-in components. So we will now look at the ports on the motherboard. Okay, we look at the ports on the motherboard. So we have the PS2 port. So before the USB ports came, before we had this USB port, we were using the PS or 2 ports. Okay, so this is it. The ones with the violet and then the green ports. That's what we were using for mouse and then keyboards before we had the USB. So that's PS2 is the port for mouse and then keyboard before the USB came. Then you have the USB port, which most of us know. The USB, the universal serial bus, is the most common multi-purpose port types. Many devices use USB ports, including keyboards, mice, and printers. I think we all know how the USB port looks like. The USB port is very common. Okay, all right. Then we have the Ethernet port. So I don't know if any of you have used an Ethernet port before, but the Ethernet port is where you can put there is this Ethernet cord you can put there, and then instead of connecting to a Wi-Fi or using the internet, you use the Ethernet. Okay, so normally there are cables you connect. So that port there is where you connect those cables to be able to use them, right? So then we have the audio port. So just like the name goes, so the audio port, the audio component support results in several small 3.5 millimeters round external connectors for plugging in speakers, headphones, and microphones. So just as the name goes, audio port. So that is where you put in your headphones, your microphones, and then any sound system. Okay, then we have the VGA or DVI ports. Okay, so the display adapter, we have a digital visual interface connector, a video graphics adapter connector, or both. So DVI is the newer type of monitor connector used with digital monitors. So in the olden days, we were using the VGA. But now most PCs are digital. The VGA is actually analog, but then most computers are digital now, so we use the DVI. Okay, so if you want to connect your PC to a monitor or a projector, that port, the VGA port, was what at first we were using, but now we use the DVI port, okay, which is digital. And then we have the serial port. Okay, we have the serial port. So I think this I doubt if we still use this port, but it was in the olden days when we used to use modems and stuff. That is where they used to put them. So they have the female and the male, and they connect them. I doubt we still use those ones. Okay, so you have the male connector and then the female connector, and then you plug them together. So normally that was like modem and stuff. That is where you used to put them. Okay. So please, are there any questions? Okay, so now let's talk about the drive connectors. So it said most motherboards have two types of drive connectors. The older type is spiral advanced technology attachment used with older hard drives. Right, so the drive connectors are ports on the motherboard, right, where you can put storage devices like the hard drive or the SSDs, where you can connect them. Okay, So these connectors, they are those that allow the computer to read and then write from the data that is on these drives. Okay. So and then we said that we have two types of them. We have the parallel. So let's first take the parallel, so that is the older type is parallel, used with older hard drives. So the older type of connector used with older hard drives is the with the first one, the parallel. And then that one, what it does is that it transfers multiple bits of data at a time, just like the name suggests. Okay, parallel. So that means that all the data that they are transferring are moving in parallel at a time. Okay, and it's although maybe you might think that because the data is moving all at a time, it is faster, but then it's a bit slower and less efficient than the serial advanced technology attachment, because the serial one, the second one, what it does is that it processes the data in bit by bit. Okay, so serial, so bit by bit. So when this one goes, and that one is a bit faster than sending all the data at once, like how the parallel does it. It sends, the parallel connector sends all data at once. So if it's like a normal road, imagine all the cars moving at once, there will be traffic. But if cars are moving bit by bit, that means that everyone gets their destinations faster. So that is how the serial advanced technology works. It sends the data bit by bit, right? Okay. So then now, since you have understood this, there are no questions. Let's move on to power supply. I said in the beginning that you talk more about the power supply. So the power supply is a component that converts alternating current power from a wall outlet to direct current power, and decreases the voltage, the level needed for computer to operate. So I think most of you know that the current that is coming straight from the wall cannot power the PC. It can power it, but then it might damage it, right? So the power supply, what it does is that it connects that current that is coming from the wall, that is the alternating current. Okay, it connects it into direct current. And direct current is what PCs need to operate, right? So the power supply takes the power from the wall and then it connects it into it converts it into AC, from DC to AC. Okay. So that is what the power supply does. It just converts the AC to DC. That is why it decreases the voltage to the amount required for each component. So it decreases the voltage just to the amount required for each component. All right, so let's look at how the power supply looks like. So this is how the power supply looks like. Okay, so if you take, I don't know if you have, I'm sure most of you have seen a monitor before. Sorry, most of you have seen a monitor before. I said a monitor, sorry, a system unit before. In system unit, you can see there is a place where there is a fan turning around. Even on your normal PC, there is a fan. Okay, so what this power supply has a fan in it that turns, and then what it does is that it cools the PC. Okay, it cools the power supply so that it doesn't overheat. It's when once you start up your PC, you can hear that sound. Okay, so that is from the power supply. Okay, so it has many bundle of colored wires and connectors emerging from it. So a desktop PC's power supply has a fan in it, and when you start up the PC, the fan starts up. Just as I was saying. So once you start up your PC and you hear that sound, when you go to the back, you can see that there is a fan that is turning. That fan is from the power supply, right? So since you have been able to see the parts of the most important part of the system unit, understood how the CPU works, and then we've been able to know how the RAM and ROM and all that works in the CPU and the system unit. We now want to see how we can solve a problem when we encounter any problem that with our PC, okay, with our system unit or with our RAM or anything. Okay, let's see what we can do or things that we can do before we even bring in a professional. Okay, after this course, after you have done introduction to computing, once you see that your computer is not running on it, you shouldn't rush and call a professional. At least you've done introduction to computing, so you should be able to, see that what is the problem, okay, before you have to call for professional assistance. So that is basically what troubleshooting is about, okay. So it's just the process of finding out why something in your computer isn't working, and then you fix it. So they say troubleshooting refers to the process of identifying and resolving issues or problems that may occur with hardware, software, or the entire computer system. So that is basically what finding out why something in your computer isn't working. Okay, so like I said, when your computer encounters a problem, you shouldn't rush and then call. You should be able to analyze what is happening. Okay, so let's see. It said it involves analyzing symptoms, diagnosing the root cause, and implementing solutions to restore normal functionality. So when you talk about analyzing the symptoms, what are we talking about? We're talking about looking for what is wrong with the PC. So let's say your PC is freezing, your PC is not turning on. You have to analyze what is happening. I think there are some people, once their PC has a problem, even they turn it on, it's not turning on now, then you are calling someone who is a technician to come and check. No, you should be able to see this is a problem, okay? This is the problem. That is maybe my PC is not turning on, or it's freezing, or it's making a strange noise or something. Okay, that is how you analyze. Then when you talk about diagnosing the root cause, so after you have been able to analyze and then know what is wrong with it, okay, after identifying the problem, maybe it could be a hardware or software error or anything. Okay, so you diagnose it to see that, okay, this is the problem. So maybe it's a hardware problem, or maybe it's a software problem, or maybe you are the one who didn't plug something well. It could be anything, right? After that, then you said what, implementing solutions to restore normal functionality. So after that, you fix the problem. If it's something you can fix, right? I'm not saying you should go and open your PCs and then you spoil it. No, I mean, it's minor things that you can do on your own, okay? So maybe there are some softwares you need to reinstall them, or sometimes it's just a cable. You need to check a cable. Sometimes you just need someone who tell you, my PC is not working. You just go and then you realize that they've not plugged some cable very well. So you just go and plug it and it's working, and they think you're a magician or you're a super. No. It's just, you just need to have these troubleshooting skills. So once you are doing this course, you should be able to show off when you have to show off to your friends. When they have a problem, try to, do something small, okay? All right, so let's look at some problems, okay, and how we can troubleshoot them. All right. I think the first problem is here. So the first problem that we will be diagnosing, okay, that we'll be troubleshooting today is no response. Okay, so no response. I think if the computer doesn't show any sign of life when you press its power button, no light, no fan. So one day you wake up, you turn on your PC, and then nothing. You don't see the light, you don't see the fan sounding, you don't hear the fan sounding, there is nothing displaying on your PC. You panic, but then you don't have to panic. You have to see what the problem is. Try to troubleshoot it first, okay? So most often these things can be that maybe it's just that your PC is not receiving some electricity or something. So what you have to do is first you have to check the outlet, okay? So check the power source. So you make sure the outlet is working, the power cord and the power strip. If you are using any, you make sure there is no break in the connection. You ensure that it is plugged properly, okay? Then you check after you have confirmed that electricity is not the issue. So after you have confirmed, and now you know that, okay, everything is connected well, what do? You try to hold down the PC's power button for 10 seconds, and then you release it. So you hold the power button, then like how we restart our phones. Normally, these Android phones, when you want to restart them, you hold the power button for just like some 10 seconds and you leave it to restart. So it's the same with the PC. You can hold the power button and then see if the problem will be solved, right? So this is the first one, that is no display, okay? And let's move on to another problem. This one, you wake up, you on your PC, you can hear the noise, everything is fine, but then your computer is blank. Okay, so your computer, when you turn the computer on, you see the light flash on its buttons or hear its phone spinning, but you are seeing nothing on the screen. So the first thing to do is to do what? Is to check to make sure that the monitor is connected and properly powered on, right? So you check that your monitor is connected very well, and also you check the monitor cable if it is properly connected to the system unit. Sometimes when the monitor cable is not connected to the system unit, you might not get, your PC might be working fine, but you might not be seeing anything on your screen. Okay, and also ensure the correct input source is selected on the monitor. Sometimes maybe your PC is having a VGA and then maybe an HDMI port. Maybe you're using a VGA, but then you have selected HDMI, so it will be inactive. So maybe you might be thinking you have a problem with your PC, but then maybe because you haven't selected the right the right source, right? Okay, so it says that if the monitor is okay, then the device is receiving power, but it is unable to complete its power on self-test. The power on self-test is a software procedure built into the BIOS. The devices must pass this basic internal testing before the operating system can load. If you have this problem after installing new hardware, so sometimes these things come after you have inputted a new hardware, or probably maybe the new hardware you have added to your PC is not compatible, or probably it has a fault, right? What you do is you try to remove it, then you restart to see if the system boots correctly without the device. Okay, so if after you have done that and then the device starts again very well, and that means that it can be from the hardware that you have put it into the computer that is making it have that problem, right? So that is what to do when you can hear your fan noise and your light is on, but there's nothing on your screen. All right. Then the next one is error message on a black screen. Okay, so if you see some gray or white text on a black background, that is good. It means that your system passed its put. If the startup stalls in this mode and displays an error message, it means that either your system is having a problem with a specific component or it can't find and start the operating system, right? So you might see a keyboard start message. For example, if you have something sitting on your keyboard that is making one or more of the keys seem pressed, and no operating system or non-system disk error message could mean that. So sometimes when you on it, the error message you will get is maybe no operating system or non-system disk error message. It could mean that your hard drives does not contain an operating system, or it could mean that the startup process could not find your hard drive. So yeah. So perhaps it is defective, or perhaps its connector has come loose. So a common reason for the non-system disk error is that you may have left a USB flash drive or external drive connected, and the system is trying to load the operating system from this device. So those of you who have installed Windows before or have tried booting maybe your computer with a hard disk or maybe a pen drive or something, you realize that if you are booting it with the bootable drive, it runs from the drive, not from the PC, right? So that means maybe if you have a bootable drive in your PC, you have to remove it and make sure that the PC will run on its own operating system, but it doesn't run on the one on your hard drive, right? Okay. So let's look at the next error. Error message on a bright blue screen. Okay. So you on your PC and then you have this blue screen. Some people call it the blue screen of death, because your PC is blue, but there is nothing you can do about it. Like the PC is just on, nothing showing. Okay, so normally this means that your Windows has encountered a problem. Okay, this usually it reports a serious hardware or memory problem that prevents Windows from starting. So normally this means that your Windows has encountered a problem, and then it doesn't want your PC to get further damage, right? So it gives you that blue screen. So normally it could be hardware problems or memory issues or driver errors, or maybe it could even be system crashes, right? So that is what the blue screen is. So for basic troubleshooting, when this happens, you just have to restart the computer first. Okay, it restarts it, and then you check if you have inserted any hardware, or maybe you have downloaded any new software that might be causing it. And also you also ensure that your RAM is properly inserted. Okay, but if it keeps on happening, let's say if whenever you keep on your machine and you're getting this blue screen, then you have to seek professional help. Okay, you have to seek professional help. All right, so let's look at probably the last one, which is PC shuts down or freezes. So sometimes you on your PC and then it shuts down on its own, or it's freezing, or it's lagging. Okay, so if your system frequently shuts down or locks up after it has been operating for 10 to 15 minutes, overheating is the most common cause. So normally our PCs freeze. Okay, they freeze when they are too heated. So those who play games, you realize when you are playing game and then you are playing for a very long time and your PC becomes very hot, the game begins to lag. Okay, that is because the PC is very hot. So normally it's overheating. Overheating is normally the common cause of freezing and then shutting down of your PC on its own. Okay, so this happens because the CPU and then the graphics card and then the power supplies, they produce it, and then if the heat is not like removed or it is not calmed down, the system automatically shut down or lock up to protect itself. Okay, because too much heat might damage the system, so it must shut down so that it will cool down. Okay, so let's see how to diagnose this problem. So try looking inside say if a component is overheating, you may have a defective fan in one of your active heat sinks. Try looking inside the system unit when the PC is running to see if you can identify a fan that isn't spinning. Okay, so if your PC is freezing, you check if your fans, maybe sometimes your fans and some of your fans are not spinning, or sometimes there is excess dirt, okay, that is blocking the fans, or there is no ventilation going on there. That is why it's freezing and then causing your PC to shut down. So when you see this, you clean the dust, you clean all the dust, and then you turn your computer on again. Okay, so you make sure that the fan is not blocked with dust. Yes, and after that you can restart your PC. Okay, to see if it's working now. So that is some basic troubleshooting skills that we all need to have, so that when you encounter a problem, you don't panic, or you don't just call in someone, technician, to come and check. Sometimes it's just basic things that they do, and then they will take money from you. You first check them and make sure that, okay, you can't solve this on your own before you bring in any technician to help you. All right. Please, are there any questions? Okay, so if there are no questions, then I'll proceed. So now we are going to talk about system software, right? And the system software, I think last week that we have the system software and then application software. So this week we are going to take the system software and see what it is. All right. So the first one the first system software we're talking about is the operating system. So I'm sure most of you have heard operating system. But then when we say an operating system, what is it? Okay, so we said that it's a set of programs that controls and supervise a computer system's hardware and provides services to computer users. Okay, so an operating system is a set of programs, okay, that controls and basically manages computer hardware. Okay, and then it also provides services for users, and then application software. Okay, so the operating system is a type of system, that system software kernel that sits between computer hardware and end users. So the operating system is actually what gives you the interface you are using on your PC. Okay, the OS is what gives you the interface, because it's the link between the user, and then the computer hardware. So that means without the computer, without OS, you can't use it, because nothing will display on your screen. Okay, so that is what the OS is. So the graphical user interface that we work with, or the command line instructions or whatever we work with, it's all because of the OS. Okay, so it is installed first on a computer to allow devices and applications to be identified and therefore functional. So without the operating system, like I said, it is non-functional. You can't use your PC. Okay, and then you say that today the user interacts with the operating system through the graphical user interface on a monitor or touchscreen interface. Just as I said, it is the OS that gives you the icons, everything you are seeing. If your OS was not on your PC, you wouldn't see anything on your screen. Okay, you wouldn't be able to interact with the hardware. Okay, the hardware will be there, all right, but then you can't interact with it because there is no mediator between, or there is no link between the user and then the hardware, right? So here it said the operating system performs the following functions. It provides the instructions to prepare the user interface. Okay, so that has been mentioned, and also it loads necessary programs into the computer which are required for proper computer functioning. Yes, so the operating system is what loads all the programs in the computer. So without the operating system, like I said, your computer is nothing. It can't do anything. It's just a white elephant without the operating system. It also coordinates how programs work with the CPU, keyboard, mouse, printer, and other hardware, as well as with other softwares. All right. Then it also manages the way information is stored and retrieved from disks. So now we know what the operating system is. We know what it does. So let's look at some types of it. Okay, there are some types of OS. So the first type of OS we talk about is the single user operating system. It supports what, as the name goes, it supports single user. So this type of operating system is normally designed for only one person at a time. Okay, so like your Windows, okay, your Windows for your personal laptop. That is an example of a single user operating system, because you are the only one that can use it at a time. All right, that is the single operating system. And then we go to the multi-user operating system. So as the name goes, also this one supports multiple users. So it allows more than one user to access the same computer system at the same time. Okay, so you can have different accounts on that OS, but then you can be at different places, and I mean you're using the same OS. So normally you have the Linux servers, and then the Unix. They are those that allow the multi-user operating system, right? And then you have the batch processing operating system. So the batch processing operating system processes batches of jobs, right? So this operating system, the tasks or jobs, okay, jobs are collected in batches. Okay, so when you submit your job to the system unit, to the operating system, you don't interact with the computer again, okay, until the jobs are completed. So you give them the job, like they do this job. Once it's given to the OS, it does that job, and whilst it's doing that job, you can't give it any other job until it is done with that job. So it works in batch by batch, right? So that is the batch operating system. Then we have the multi-processing operating system. It is capable of handling multiple CPU at the same time. So this operating system, it can have like this multi-processing operating system, it can have like 2 or more CPUs, okay, processors processes. Okay, it can have two or more of them simultaneously that perform tasks faster and more efficiently. So just as the name goes, multi-processing. I mean that it has more processes that performs works at the same time. That means it makes it faster. It increases the speed and also the performance. Okay, so I think Linux, okay, most Linux OS has this multi-processing operating systems. And then we move on to time-sharing operating system. So time-sharing operating system allows multiple users to access a single computer system. So what time-sharing does is it gives each user a small time slice of the CPU, right? It gives you a part of the CPU, a small time when you are using it. And then it gives another person also a small time. Another person also a small time. So it creates that illusion that you are all working together, okay, at the same time. That is how the time sharing. It gives each one small time to work. Small slice of time. The CPU small slice of time. But then it makes you feel like they are all working together. That is how the time sharing works. It shares the time. Okay. Then we have the real time, the last one, the real time operating system. So you say that allows the computer to control tasks performed by other machines and people by responding to the input in the required amount of time. So normally these operating systems, they are operating systems that they cannot tolerate delays. Okay, they are used in places that we can't tolerate delays. Like let's say they are used in this medical sectors where you can't tolerate delays. Once there is any delay, then that means there will be a loss of life or something. Okay, and they are also used in traffics and all those things. That is where the real time they take input and then they do them at the same time because there shouldn't be any delay. They are always accurate. All right. So that is it about the operating system, right? Then so here are some OS. Some OS. I think we all know about the Windows. Most of us use the Windows, and then the Mac OS. The Mac OS is for the Apple laptops. Then we have the Linux, the Ubuntu, and others. And we have the Unix. And then we have the network OS, that is the Ubuntu. And even on our mobile phone, right? The Android phone you are using is an OS. Okay, Android is an OS. We have the iPhone. The iPhone users are also using the iPhone OS. Okay, so yes, that is some examples and some types of OS that we have. So then we are still talking about the system softwares, right? We've spoken about OS, operating system. Now let's talk about translating program. So this language translator program are programs for converting programs in other languages into machine language instructions so they can be executed by the computer. So, machines or computers do not understand English. They don't understand the language you speak. Okay, so they don't calculate this. They don't understand anything. The only thing they understand is zeros and ones. Okay, zeros and ones. They don't understand any other language. So what the translating program does is that when you have written your English or you are written your tree to the computer, what the computer does is, what the translator program does is that it converts whatever you have written into machine language, which is the zeros and ones. Okay, so anything that you write in anything, like even numbers, when you give it to the PC, it converts them into zeros and ones or binary before it will understand them. Okay, it doesn't understand what. So the language processes, we have some examples. We have the assembler. Okay, so the assembler, this language processor converts the program written assembly language into machine language. So as assembly language is basically those languages that are used from the manufacturers when they manufacture those hardcore programming languages. Okay, those are the assembly languages. So it converts, that's what the assembler does. It converts those languages into machine languages for the PC to understand. And then we have the interpreter. So the interpreter converts high-level language into machine learning language, right? So I'm sure most of you have heard about some programming languages like Python, JavaScript, and those things. It is the interpreter that converts the languages that you write to what the computer will understand. We have other things like a compiler, which I mean it's also works with the high-level language. It also converts, I mean, language, high-level language like the Python and that stuff into machine language before it executes them. We have the linker, and then we have the loader. All right. So then the third system software we talk about is the utility program. Right. So utility programs are usually supplied by computer manufacturers. These are also known as service programs. They enhance the function. They enhance the function by performing tasks related to the control and allocation of computer resources. Okay, so these utility systems are special system softwares, okay, that are designed to help maintain and then manage, then also protect, and protect the computer system. Okay, so what they do is that they support the operating system by performing some tasks. Okay, they support the operating system by performing some tasks. Normally, these ones are normally produced by the manufacturers of the computer. Okay, they are normally installed along with the operating system and all those things. All right, so let's look at some examples of utility programs also. You have the data recovery. The data recovery is used to recover a file or information that has been deleted. So when you delete a file based on accident, let's say an accidental deletion, right? Or maybe there's a system crash or there's a virus or something that deletes some files on, you lose some files. Okay, is that you can use this data recovery to recover some of the data that you have lost, right? Okay, and then we have the screensaver. So it prevents a monitor display screen from being etched by an unchanging image. So it's a utility program, okay, that it prevents damages to a monitor's display screen by replacing a fixed image with moving images or blank screen. So you can, I don't know, I'm sure most of you have used the screensaver before on your PC, so that when your screen is there, maybe you are doing something on your screen and you leave it for some time, maybe 5 minutes time. When you come back, there are some, you see these ribbons flying on your screen, or sometimes there is maybe some small animations going on your PC. That is what the screensaver does. So it comes in so that there wouldn't be a fixed image, okay, on your screen. Okay, that can cause a screen burn or something. Then we have backup. Okay, so backup, as we all know what backup means. Backup means we all back up our WhatsApp chats, right? We back up our WhatsApp chats, we back up our images to iCloud and all that. So backup is used to make a duplicate copy of the file on the hard disk in order to maintain continuity of the operation. So the backup, it creates a duplicate copy. That's what it does. It just creates a duplicate copy of the file or data and store them in another location, so that when you lose them, you can get them. Okay, so it prevents data loss, and also it helps maintain the continuity of works if the original data is lost. So if you lose your original data, you can always find them back because of the backup. Okay, then the next one is the data compression. So it says removing redundant elements, gaps, and unnecessary data from a computer's storage space so that it can take less space to store and transmit data. So sometimes when maybe there are some data, it can have some redundant files. When it's redundant file, that means some files, they appear so many times, or then there are some unnecessary data in it. Okay, so what the data compression does that is remove this unnecessary data from them. So sometimes you can see when you are saving some big folders, right? You can zip them. When you zip them, or there is this format called the RAR format. I don't know if you know the RAR format or the zip. I'm sure most of you know the zip folders, right? When a data is zipped, the data compression that is used, okay, it makes it smaller by removing some unnecessary data and all that. Okay, so that is what the data compression is about. Then also it does virus protection. Okay, it also protects the PC from virus. Okay, and then also sort text editors. Then the fourth one we talk about is the device driver. Okay, the fourth system, you're still talking about system software. So the fourth one is the device driver. So we see that the device driver is a system software. It enables device communication with the OS and other programs. So it's also a system software that allows the operating system and then the application programs to communicate with hardware devices, right? So it is the device driver that allows your operating system and your application programs to communicate with your hardware. Okay, so they basically enables the OS to understand the hardware and also to control it. Okay, and then it's like a bridge or a mediator or a link between the hardware and then the software. So you can have some on your PC. And when you go to your drivers, you can have something like a printer driver, you have a keyboard driver, we have an internet driver. It's those drivers that make sure that everything is working. So because sometimes someone like maybe they have lose the driver from the mouse driver from their PC. If you should lose like something like the mouse driver from your PC, right? That means when you connect a mouse to your PC, the PC cannot detect that a mouse has been connected because you lost that driver. Or it could be a keyboard driver. When you connect a keyboard, the PC wouldn't be able to know that you've connected the keyboard. Okay, so that is it about the device driver. And then we talk about the firmware. So the fifth one is also a system software, the firmware. So it enables device control and identification. So it's also a type of system software, okay, that is stored in device's memory. Okay, so it enables device identification, controls the basic operating of the hardware, then starts and manages hardware before the operating system loads. So the firmware is basically the one that controls the basic operation of the hardware. So if you move your mouse and it's moving and everything in the firmware. So we have firmware in routers, you have them in printers, even in your mobile phone, your smartphones. Okay, all right. So that is it about system softwares. System software, yes. So firmware, using firmware to end for system softwares. So today we have been introduced to the system unit. You've been introduced to the CPU. You've been introduced to how to troubleshoot your PC in case you have a problem. And also you have been introduced to the operating system, right? So that is where we'll be ending our lecture today, lecture 2 for today. So you can go and read more about all these things we've talked about, okay, to get more knowledge about them. All right. So that is where
Hello,
we end our
Steven.
lecture. Hello, Doc.
Hi. Yeah. So thank you for the. Do we have any question? Is someone having any question? Do we have any question? Do we have any question?
No, madam.
Yeah. So let me add a little voice to what Steven just said. So with the assembler and then the interpreter, I'm getting a feedback. I don't know whose speaker is on. Put off your videos and then mute yourself. Steven, put off your video. Dominic, put off your video. Yeah, so with the assembler and then the interpreter, they are all translators, okay? But the difference between an assembler and interpreter is that assembler, everything that you type on the computer, it takes them a whole and then translates them into binary, that is zeros and ones. It takes all the documents at a go and then translate it as ones. But with the interpreter, it takes them line by line. It interprets them or it change them to binary line by line. So you to take the first line, translate it to binary, give it to the system. It takes the second line, translate it. So if you are asked the difference between an assembler and an interpreter, the main difference is that the assembler translates the whole document at a go, but interpreter translates line after line by line. Is that clear? Yes. So we've been able to exhaust what we have in our book for unit 2. And you know, every unit has some sessions under them. So the unit 2 we covered 6 sessions. Session 1, session 2, session 3. So when you open your book, that is the main book, the model. Every session has some questions under it. So, for example, when you go to Unit 2, Session 1, after you have read everything, there are some questions under them. Try and then solve those questions. So, because we have been able to finish the Unit 2, it means that tomorrow, the 1 hour, we are not coming online. Use the 1 hour period to revise the notes and then to solve all the questions within unit 2. That is when you take section 1, the questions under it, you solve them, you read, you take section 2, you solve the questions, and that will give you much more understanding of what we have learned here. And so during quizzes and exams, you wouldn't have to go through the stress of going to look for questions and stressing yourself, sleepless nights and others. So I will encourage you and I will say that use the 1 hour much more profitably. Use it to revise the lecture slides, use it to read the model, the main book that was given to you, and then use it to solve the questions. When you read and then you solve the questions and there are some of them that you don't understand or some that you need clarification on, then next week during our lecture, we'll ask any question before we proceed with the unit 3. So take note of that. And the second task is that the course rep should do well to get me the names and index numbers and then I think your centers for all those in this class for the presentation purpose. So get me the name. So what you can do is that you create a Google form, name, index number, center, and then you share the link on the platform that you have created for everyone to click and go and input their details there. The deadline for inputting your details, so Courseware, do well to create the link today so that by next week we would have the list, and then I believe you know that you'll be doing some presentation. Then we can share it into groups and then you people can prepare for the presentation. So if the coursework is online, do well to create the Google form and then put the link on the WhatsApp page for them to fill in their details. After they have filled in their details, you get the details in a Word document and then you send it to me. So take note of this. Any question?
Hello.
Yes, madam.
Hello, madam.
Yeah, I'm listening.
I don't know if they have a particular book for the computing. Because I don't find myself in computing. Please, I said.
Hello.
Hello, madam.
Yeah.
I don't know.
Well, you finish your course.
So last week they created a WhatsApp group for this course. So I think they can share the link on the in the chat, and then if you are not there, you can click and then join the WhatsApp page. Is that clear?
Madam. Hello, madam.
Yes, please.
Yeah.
Yes. Please, what is the course rate?
Come again.
What is the course rate?
How do you expect me to know the course rate? Were you here last week? I believe last week they met and then they created a group. Someone has put the link on the chat. So click the link and then join the page, and I believe you'll be able to. It is a class who choose their course rep. It is not a lecturer who choose course rep for the class. So the link has been put in the chat. If you know you are not part of the WhatsApp group, click it and then join it.
Okay, thank you, madam.
I myself, I don't even know who the course rep is, but I know someone sent me a message to get the slides. So, any
Thank
other
you, madam.
question?
And so, madam, please, if it is possible, the class rep to or the course rep to send the link on the platform again so that some of us can get
But I just
attention.
told you that they have pasted it in the chat right now. So you click and then you join. Where else should it be posted? It's already
Hello,
in this
madam.
chat. Or you,
Madam.
Daniel or someone posted it.
Hello, madam.
Yeah, hello.
Yeah, please. My own, I offered education. So later on, that is online. I've moved back to HRM, which is human resource. I last called Madam Admin. So she requested for my admission letter, the previous one. So I sent it to her. But till date, I've not received a message based on
I am
maybe
not
the
an
registration.
administrator. You know, this you are talking about is an administrative something. I'm a lecturer, I'm a tutor. So you still have to follow up from the administrators.
Okay.
Mm. Is that
Thank you.
is everything? Any question? And as I mentioned last week, we record the session. So when you come online, put off your video so that we can get a good recording for you. We don't need to see your faces. So you make sure you put off your video anytime you join the class. So I'll repeat, tomorrow's 1 hour, you use it for your private studies and make sure you answer all the questions in Unit 2. Do have a nice weekend then if there are no questions.
Madam, please, how do we get the recording?
So there is an administrator here who is responsible for the recording. I myself, I don't have control over the record because they gave me the link. So reach out to the coordinator for the recording and then make sure you listen to it again. The person should be online because they do the recording. So reach out to them, any of the administrators or coordinators. All right, so have a nice weekend. I'll see you next week. So use tomorrow's 1 hour to do your personal studies and answer the questions in the book. All right, bye. Stephen, thank you so much.
Hello, guys. Dennis, please drop your contact here so that you can contact you. For those who are not able to click on the link to join the group, can also contact you so that you add us. Well, if you are here, try and do so for us. I think so far you're done for the day. Good. Goodbye.
Please, what is happening? Is it over?
Over on mute you are in. It is in over Kasavu. In English and abroad. Oh, yeah, yes, over answer. So please, where is the comment section? What time did you?
Please, is the session over?